Deepfakes and manually edited videos look identical to authentic footage. A video file holds three distinct formats: a video stream, individual image frames, and an audio track. We authenticate these using a four-step framework: legal capture, origin check, tampering analysis, and AI detection. If we skip any of these structural checks, manipulated footage can easily bypass our scrutiny and slip straight into the public record or a courtroom. Let's start with the legal foundation. There is a strict difference between a video being authentic and being reliable. Authentic simply means the digital file itself hasn't been altered, but that doesn't mean it's reliable. A perfectly authentic video could still depict a completely staged event. To prove a file's authenticity in legal proceedings, we establish an unbroken chain of custody. We generate a cryptographic hash, a SHA-256 fingerprint, that seals the video file, proving it hasn't changed a single byte since the moment it was captured. Once the file is secured, we verify its origin. Using open-source tools like the Amnesty International Data Viewer, we extract hidden metadata from the file to pinpoint the exact time and date it was originally uploaded to the web. This is the InVid verification interface. It extracts a vertical sequence of keyframes. Running reverse image searches on these thumbnails determines if the footage was recycled. Investigators can also isolate frames to check copyright and apply forensic filters to spot manipulation. Securing that cryptographic hash and checking the file's origin immediately prevents investigators from wasting resources, analyzing a video that is legally inadmissible or simply stolen from a completely different news story. If the origin checks out, we scan for manual tampering. This frame is a classic example of spatial tampering, manipulating pixels within a single image. Here, a cartoon diver has been artificially pasted directly over the original footage of a sea slug. Next, we look for temporal tampering. This diagram illustrates how time itself is manipulated within the video stream. If a sequence of frames is dropped or extracted, the timeline snaps shut, creating a jump cut designed to hide what actually happened. Let's test your eye. Pause the video right now. Look at the two examples on screen and identify which one shows spatial tampering and which one shows temporal tampering. On the left, that abrupt gap in the visual flow gives away the temporal jump cut. On the right, the repeating, blurred logo on the shirt is a clear artifact of spatial cloning. While the human eye can catch those kinds of sloppy edits, highly sophisticated manipulations require us to analyze biometric data that our eyes cannot physically see. GANs create convincing synthetic faces, but analyzing geometry reveals mismatched lines around the jaw. Furthermore, RPPG liveness analysis exposes them. Real human faces exhibit microscopic color changes from blood flow. Notice these human data nodes pulse rhythmically, while synthetic nodes remain flat. Because deepfakes are constructed mathematically rather than captured from a living person, they fail this biological liveness check. This chart visualizes audio-visual synchronization. It compares the sharp waveform peaks of spoken phonemes against a line graph measuring the subject's mouth opening. In synthetic videos, we detect a distinct out-of-sync timing gap between the audio track and lip movements. To process these complex checks, enterprise security teams use platforms like CloudSec or PinDrop Pulse, while independent investigators rely on accessible OSINT scanners like Deepware or the InVid Deepfake tab. Deepfakes are designed to deceive human perception, but they fail when subjected to the combined physics of human biology and acoustics. Let's track the journey of our hypothetical video. We secured its chain of custody hash, ran reverse image searches on its extracted keyframes, analyzed it for spatial and temporal tampering, and finally subjected it to RPPG liveness checks. Surviving this technical gauntlet provides the foundation for authenticity and reliability. From here, the footage must still clear legal hurdles like relevance and hearsay rules to be ruled admissible by a court. Here is the final three-pillar forensic checklist, covering legal protocols, manual tampering checks, and AI detection techniques. Take a screenshot of this right now so you can apply this exact framework to your own investigations. In an era saturated with synthetic media, truth is no longer based on what you can see. It is based strictly on what you can cryptographically and forensically prove.